In the previous lesson, we have discussed about normal distribution, and our today's focus would be on a standard normal distribution, and we will discuss what is not a standard normal distribution and how we can determine the areas under a standard normal distribution. In our today's module, we will learn how we can convert the raw data to a standard normal distribution, meaning to G-score, and how we can convert the G-score to raw data, and how we can interpret the graph of a normal distribution, then how we can find the area under the standard normal curve. So let's first start with what do you mean by a standard normal distribution. So a standard normal distribution is also a normal distribution, but for this distribution the mean would be 0 and the standard deviation would be 1. So for a standard normal distribution the mean is 0 and the standard deviation is 1. So for a normal distribution, if the mean is 0 and standard deviation is 1, then we call that a standard normal distribution. As I was saying earlier, for a standard normal distribution, the mean is 0 and the standard deviation is 1, and G-score help us to understand like how many standard deviation away certain value is from the mean. And for the G-score conversion we use this formula. We'll discuss that in the next slide in details. So for a value of x, we can get the corresponding G-score by using this formula, where mu is the mean for the distribution and sigma is the standard deviation for the distribution. Then the formula for the G-score is that x minus mu over standard deviation, which is sigma, right? If the G-score value is near 0, that means the measurement is near the mean. If the G-score value is positive, that means the measurement is above the mean. And if the G-score is negative, that means the measurement is below the mean. Now we'll see with an example how we can use a G-score in real context. So as for example, for making pizza, we all use cheese, right? And a certain pizza shop is also using cheese for making pizza, and the average amount of cheese they use for making one pizza is 8 ounces with a standard deviation 0.5 ounces. Now for a certain pizza it is found that they have used 6.9 ounces of pizza. Now the question is what is the related G-score associated with that, and whether the amount of pizza they are amount of cheese they are using for making this pizza is below 3 standard deviation. What does that mean is that we have seen earlier, right, that a 99.7% observation should fall within 3 standard deviation range, and if this amount of cheese they are using fall below the 3 standard deviation, that means they are basically using less pizza for making more profit, right? So now let's see how we can calculate G-score for this case. So the mean amount of cheese they use for making pizza was 8 ounces with a standard deviation 0.5 ounce, and the observed value for a certain pizza was 6.9 ounce. Now we have to calculate the G-score associated with this value. So by using this formula we can calculate the G-score, where x is the value and mu is the mean and sigma is the standard deviation. Then after using this formula we get the G-score associated with 6.9 ounce is negative 2.2. That means the amount of pizza the amount of cheese they are using for making this pizza was 2.2 standard deviation below, right? 2.2 standard deviation below. So still like that is like within the range of 3 standard deviation, right? Still within the range of 3 standard deviations. So it cannot be tell for certain, like, you know, they are not maintaining the standard, right? For certain pizza it might happen like, you know, the amount of cheese they are using is say 2.2 standard deviation below, but since it is within the 3 standard deviation range, it cannot be said that, you know, they are not maintaining the standard for making the pizza, right? earlier we have discussed like if we have the raw score, then how we can convert that to standard GS score. But if we also have the GS score, then we should also be able to convert that to raw score, right? And by using this formula we can do that, where H is the raw score value and mu is the mean, G is the GS score, and sigma is the standard deviation, right? So then if we have the GS score, then by using this formula we should be able to calculate the raw score. And in the next slide we will see how we can do that. So here we have the information of commute time for Ira from home to school, and her average commute time is 17 minutes with a standard deviation 3. And for a commute time of 21 minutes, we have to calculate the GS score, and we have to determine whether the GS score will be positive or negative for a commute time of 21 minutes. And the second question is, now we have the GS score. The GS score is negative 2.5, and we have to find the commute time associated with the GS score, and whether this time is reliable or not, like whether this time is reliable for Ida to commute from home to school. We have already discussed like how we can calculate the GS score, right, from the raw data. So we basically used this formula earlier. So for now, for the commute time of 21 minutes, just by using this formula we can calculate the GS score, right? So here our x value was 21, and then mean was 17, and standard deviation was 3. Then this formula gives us the commute time is 1.33. That means like for a 21-minute commute time, which is 1.3 standard deviation above, right? And here the value for G is positive. Why the value is positive here? Because the average commute time was 17 minutes, and 21 minutes is above 21 minutes is above 17 minutes, right? Therefore the GS score associated with 21-minute commute time is positive, right? And now in the next slide we will see, if we have a GS score, how we can calculate raw score, right? In the previous slide we have seen how we can calculate GS score from raw score, and now in this we will see how we can calculate raw score from GS score. And we can do that by using this formula, where mu is the mean, G is the GS score, and sigma is the standard deviation. Then the raw score associated with GS score negative 2.5 is that, where 17 is the mean and 3 is the standard deviation, and the number we get is 9.5. That means the commute time is 9.5 associated with GS score negative 2.5, and which is a extremely fast commute time, right? And even though like which is like within 3 standard deviation limit, but she has to be extremely fast to make these within 9.5 minutes, right? So now we'll see how we can use the normal table to get the area under the curve, or to get the probability associated with the GS score, right? So here we have the GS score negative 1, and we have to find the area left to this G value, like what would be the total area left to each Z value. And then the next question is, what would be the total area, what would be the area left to the G value of 1.18. Now we'll see how we can find the area to the left side of the G value, right? And here the G value was negative 1. Therefore we basically need this area. We need to find what is this area, right? Here we have the G value negative 1, so we are interested to find this area. Now we can use the G table to find this value, and there are different types of G table. So some of the G table give us the value or area to the left side of the G value, or some of the table give us the area to the right side of the G value. Here we are using a left G table, so that will give us the area to the left side of the G value, right? So now the G value we're interested is -1. So we have to look where is the -1 here. This point is the -1, right? Here we have the -1 and -1.00. So -1 and then this is 0. Therefore, this value would be the area to the left of G value, right? And the G value in our case was -1. And the value is 15.15866, and if you round that, which is 0.1587, that means the area to the left side of G value -1.00 is 0.1587, right? I think now it is clear to you like how for G value -1 we can get the area. We can get the area to the left side of this G value, right? And in the next slide we will see how for another G value we can calculate the area, so that it's become clear to you like how we will do this table. So now we will see how we can find the area below G value 1.18. That means we need this area, we need to find this area, and let's see how we can use the G table to find this area. So here our G value is 1.18, so we have to look where we have 1.1, right? Here we have 1.1, then we have to see here where is 0.08. so here we have 0.08, so 1 point, that means like 1.1 plus 0.08, that is 1.18, right? So here we have 1.1, and then where is 0.8 here? So that means this value would be the area to the left side of 1.18. So here we have 0.08 and here we have 1.1, right? So 1.1, 1.18. so this area, this value would be the area to the left side of 1.18. Suppose we need to find the area to the left side of G value 0.76, say 0.76, then what we have to do, we have to look for where it is 0.7. so here we have the 0.7, then 0.75, right, or 76. So the 5, then for 0.75, the area to the left side of 0.75 is 0.7734, and the area to the left side of 0.76 is 0.7764, and so on. Suppose somebody tell you to find the area to the left side of G score 1.49, then what we have to do? So we have to first look where is 1.4. so here we have 1.4, then you have to see here where is 0.09, right here. So we have to go from here all the way where is 0.09 and here. So here, then for 1.39, the value to the left side of G score 1.39 is 0.9177, and so on. And the value say to the left side of 1.47 would be 4.7 would be 0.9292, right? So this area, this value is the area to the left side of 1.47, right? Now I think it is clear to all of you like how we can find the area to the left side of a G score from a G table, right? The area to the left side of a G value is same as the probability that G value would be less than that value. So the area to the left side of G value of this is same as the probability that G value would be less than that value. And we have seen from the normal table, standard normal table, the value is 0.1587, right? And here as well, like the area to the left side of the G value is same as the probability that G value would be less than 1.18, and from the G table we have already know this value is 0.8810, right? So let's try to answer this question. As the G value increases, do the area to the left side of G increases? So you can see here as the G value increases, so here the G value is -3, here the G value is -2. So as the G value increases, the area to the left side is increasing, right? Here the G value is -1, so which is greater than -2, so the area to the left side is increasing here. So as the value of the G value increases, the area to the left side increases, right? I think that's very clear to all of you. So the next question is, if G value is negative, is the area to the left side of G less than 0.5? So here, look into this. So this area, so here we have the 0 value, this area here is 0.5, right? So this area here is 0.5 and this area here as well is 0.5, since the distribution is symmetric, right? So if the G value is negative, here you can see G value is negative on this side, like to the left side of 0. So if the G value is negative, then the area must be less than 0.5, right? And if the G value is greater than 0.5, if the area is greater than 0.5, then the G value must be positive. So in that area, anywhere in that area, the area to the left side would be greater than 0.5, right? Since this area to the left is 0.5, so for any G value to the right side would be, the area would be greater than 0.5, right? And in that case, the G value is always positive. You can see the G value here in this range is always positive, right? If the G value is very small, as for example here the G value is -3.49, so that would be somewhere around here, right? Somewhere around here. So if the G value is very small, then the area to the left side it's become almost 0, right? So for a standard normal distribution, if the G value is less than -3.49, then the area to the left side of that become virtually 0, right? And if the G value is greater than 3.49, which is somewhere around here, then the area to the left side become 1, right? Here you can see like almost all the observation is to the left side of 3.49, right? So therefore this area is 1, right? And if the G value is 0, then the area to the left side would be 0.5 and the area to the right side as well is 0.5, right? So here we have the G value 0 and the area to the left side is 0.5, area to the right side is 0.5, right? So far we have learned how we can find the area to the left side of some G value, and now we will see how we can find the area in between two G values, and how we can find the area to the right side of G values, and we'll discuss that in the next slide. Now for this question, what is the area we need to find? We need to find the area between G value 1 and 2.10. That means here we have the G value 1 and here we have say 2.1. Therefore we need to find this area, right? We need to find this area. And how we can find that? We have seen like we have the left G table, right? Left G table value. And therefore in the left G table value we just have the area to the left side of some values, right? So now how we can use the G table then? So what we can do is that we can get the value for 2.1, we can get the value this area, right? And we can also get the area which is below 1. Then from this area which is below 2.1 we can subtract the area which is below 1, and that will give us this area, right? And for this one what we can do, and this one what we need to do, we need to find the area that is to the right side of 0.94. That means the area here, say we have 0.94, then we need to find this area, and we will see how we can do that. So now let's see how we can find the area between two G score. Here our G score is 1 and 2.10, so we have to find the area in between these two values, right? And how we can do that? So to find the area between two G score value, first we need to calculate the G value G value that is to the left side of the large G score, and then we have to also find the G value to the left side of the smaller G score, and then from this one we have to subtract this one, and that will give us the area in between the two G score. So we from the G table we can find this area. So what we have to look, 2.10. Where is 2.10? So here is 2.1. so this value is to the left side of G score 2.10, which is 98214, and 9821 we can round that it to the 4 digit, like 9821. And then we need to find the area that is left side of 1. Where is 1 here? 1 is here. So here 1 is here, right? Which is 84134, which is 8413 if we take up to the 4 digit. And then to get this area which is in between G score 1 and G score 2.1, what you need to do, from this area we need to subtract this area, and that give us this area in between the G score 1 and G score 2.1. I think now it is clear to all of you, right? Like how we can find the area in between two G score. So now let's discuss how we can find the area to the right side of G score 0.94, and we can in fact do that in two ways. So the table that we are using always give us the area to the left side of a G score, right? And here we need to find the area to the right side, and we do not have that directly from the table. But what we can do is that, so here, say for here we have the 0.94, right? 0.94, and we need to find this area. But from the table we cannot do that. But what we can do, from the table we can find this area. Right? So we can find the area that is left side of the G score 0.94, and then we know the total area is always, for a probability distribution, is 1. Now from the 1, if we subtract this area, if from the total area, that means for total area is 1, if we subtract this area, that basically give us this area, right? We can in fact do that. So by using the G table, we can find the area where, find the area to the left side of a G score. Our G score was 0.94, and this area is 0.8264. And then what we can do to get the area to the right side of this value, we can subtract these values, this probability or this area, from the total area, right? For a probability distribution, the total area is 1 minus this area. So that gives us the area to the right side of 0.94. So that basically gives us this area, right? And another way we can also find this value, we know that the standard normal distribution is symmetric, right? Now the area to the right side of, therefore the area to the right side of 0.94 is same as the area to the left side of negative 0.94, right? Since the distribution is symmetric, here. Therefore what we can do is that we can find the area to the left side of negative 0.94, which is this value, and that is basically same as this area, right? The area to the left side of negative 0.94 is same as to the area to the right side of 0.94, right? And here you can see this area is the same. If you look into the G table, you will see like this value are the same. So by using these two methods, we can get this value. We can get the value to the right side of a G score, right? So now I think it is clear to all of you like how we can get the area to the left side of a G score, how we can get the area in between two G score, and how we can get the area to the right side of a G score. So to summarize what we have learned like how we can convert the raw data to a G score, and how we can also convert the G score to a raw data, right, to a raw score. And we also know like what is the standard normal distribution, and then we also know how to calculate the probability or the area under a G score by using the normal table, right?